My mission this week was to bring two people in contact with each other, and that happened this weekend. Dr. Gerald Pollack, who's absolutely amazing presentation here yesterday afternoon. I had to change the schedule about 3 times to make sure that his presentation wasn't at the same time conflicting with Dr. King. And we made that happen. So Dr. King got to see Gerald Pollack yesterday, and Gerald Pollack got to see most of your presentation yesterday over at Tesla Tech. So anyway, I'm just delighted to bring up to you our next speaker, Dr. Maury King from Tesla Tech. Come on up.
Oh, give me 1 minute. Yeah, I'll give you a minute.
I'll entertain the crowd.
Go ahead.
I want to thank Greg for inviting me here today, and I was just thrilled to meet a number of you and just hear the conversations. It's an effervescent intelligence. I'm drunk on your ideas. There's such creativity that I want to give you guys an applause. It was terrific. What I put together is. I'm an engineer. I was an electrical engineer, became a systems engineer back in 1974. We had the oil crisis and all the gasoline lines. I coincidentally had a roommate who was in the general relativity. He had that big book by Meisner, Thorne, and Wheeler, Gravitation. In the back of the book, last 2 chapters were discussions of zero-point energy. It was Wheeler's theory of geometrodynamics. And I go, holy cow, he was talking about fluctuations of electromagnetic field energy with extraordinary energy densities. It was down to the Planck length, 10 to the minus 33 centimeters. That's 20 orders of magnitude below the electrons. And I went, holy cow, here I am in graduate school in engineering, and I've never heard of it. And so I approached my engineering professors in the engineering school, not one heard of it. And I go, gee, why didn't you tell the engineers? The physicists knew about it, so I went over, and sure enough, I met some physics professors and things like that. And I thought, well, I'm going to start up again. So here I finished my coursework, my PhD in systems engineering, and I'm jumping in to graduate physics and quantum mechanics and things like that. And people say, are you crazy? That's all complicated stuff. Why are you doing that? And I said, well, why to learn it, right? To see where they're at. And sure enough, the physicists were stuck too. They knew that the energy was existing, and I asked the obvious question: can we possibly tap it as an energy source? And they go, oh no, it's random, it's chaotic, the law of entropy says you can't do it. They had a model like a heat bath where everything is independent. And as I looked at the theories of the zero-point energy, I said, wow, how could it possibly be tapped as a source? And then in 1977, just in the nick of time, Ilya Prigogine wins the Nobel Prize in chemistry, but it was a system theory Nobel Prize on how a system may evolve from chaos to self-organization. And I go, wow, and it required certain conditions of the system. And those conditions were, it had to be nonlinear, far from equilibrium, and had to have some type of energy flux through it. And it turned out that the zero-point energy theories of Wheeler in particular describes an energy flux of the zero-point energy flux, fit the theories of Prigogine. And here I wanted to get my thesis in systems engineering, and Prigogine was a systems engineer. And sure enough, I studied that work, the whole bank of work in self-organization, and there's journals on it, on system engineering, and I said, I want to apply those theories to the zero-point energy. And everybody was shocked. None of my professors wanted to deal with it. They didn't know about it, but they knew me, and they were good sports in some cases. But just then, 1979, I get invited out to Eyring in Utah. They were interested in pursuing some of the experimental work, and that's where I stayed ever since. We're almost there.
I'm so sorry.
But the good news is I'll be able to go through the slides quicker because I'm telling you the information on the slide.
Give him an extra 5 minutes. I'm so sorry.
Then, of course, I agreed with this. You can't get your thesis unless there's an experiment. And of course, you have to prove this is out of the paradigm. It's not belief. And then what I'm going to share with you very rapidly are slides of what I consider some of the best of the experiments to show that self-organization is occurring with the zero-point energy interacting typically with plasmas, and new work this year show it possibly interacts during water cavitation. And so we'll be looking at some of those experiments very quickly. Excellent. And so these conglomerates involve charged clusters, plasmoids, the cavitation bubble, especially the reentrant jet being emitted from the cavitation bubble. And if this is really true, the implications are that large vortices of plasma likewise cause entrainment in the zero-point energy and creates a coherence in it, actually ends up grabbing a net energy gain out of it. And typically in plasmas, we don't see it because we're not looking for it. It's out of the paradigm. It's forbidden to be looked for in standard academia. But so the inventors typically stumble across it by doing the right stuff. Okay, could you pour me a glass of water?
Absolutely, yes.
Bottom button.
Typically throughout the history of science, probably since Newton, there was a belief that in an ether. Maxwell's equations was an ether theory. It was typically hydrodynamic in nature. The vocabulary, thank you, of electrodynamics and vocabulary of Maxwell's equations are basically fluid dynamics, fluxes, things like that. They have source sink models. Was very nice. So, but in 1905, the Michelson and Morley experiment comes along. Einstein's theory of relativity comes along, and it's very elegant as it unifies the electric field with the magnetic field. And everybody threw out the ether, but they only measured the wind of a static ether. But Dayton Miller furthered the work of Michelson Morley. He worked with Michelson on the interferometer experiment. He made an interferometer 10 times larger. It was 10 times more sensitive. He did experiments on Mount Wilson. At ground level, he got approximately the same result as Michelson and Morley did, but on Mount Wilson, he got evidence for an ether drag theory. As James DeMaio wrote a wonderful paper. It's on the way. By the way, you don't have to take notes because I'm going to tell you at the end how to get all these slides. And at the bottom of every slide is a reference. And you'll get this slideshow and yesterday's slideshow from one website. So along comes in 1930, quantum mechanics comes into play. The vacuum now is a surging sea of fluctuations, electromagnetic field fluctuations. It gives rise to the uncertainty principle, and it gives rise to pair production, a production of electron-positron pairs popping out of the turbulent vacuum. I said, there's my first evidence of self-organization in the vacuum. So look what we have. We have a gap in science, 25-year gap from 1905 to 1930, where it is believed, because of the Michelson-Morley experiment, that empty space is empty. Prior to that, we believed in ether, and after that, we believed in the fluctuating vacuum, which, by the way, is a much better model for an energetic substrate, because it's modeled more like a turbulent plasma at the microscopic domain or at the Planck domain. Therefore, but this 25-year gap has dominated the belief of all of science. Everything you learn in school, the vacuum's empty, especially the engineers. And the engineers are the guys that do the stuff. They want to see real stuff. So when I was at last year's conference back in Washington with a lot of engineers from NASA, I still couldn't get any traction with them. Their beliefs just block them. They think the physicists that believe in this stuff, oh, they're just kooks too, with the Big Bang and all that stuff. They dismiss them. The engineers, truly in their beliefs, say the vacuum is effectively empty, and I will ignore all ideas associated with tapping it. If you go to the literature, it's a well-open question what can be done with the vacuum in the future. In the beginning, Boyer was the leading proponent in the United States, and he wrote a series of papers that culminated in that all quantum effects can be described by matter's interaction with the vacuum energy. The hydrogen atom could be modeled, and Plutov, teamed with Hayes and others, to show how the hydrogen atom can be modeled from the vacuum energy. It can be an energy source without violating thermodynamics. Very important paper, because when people say it'll violate thermodynamics, the experts say no. It's an open question. You've got to prove it by an experiment. How gravity can rise from it as well, and probably the most exciting paper is how inertia is sourced in the vacuum fluctuations, meaning all the elementary particles are intertwined with it. If you can start to create a technology that controls the vacuum, you can create propulsion of a sort that we can undergo abrupt accelerations without feeling inertial stress. The model in Willer's geomicrodynamics was essentially a turbulent plasma with electric flux entering and immediately leaving R3 space called quantum foam, is what he called it. The flux through any hole, little mini white hole, was on the order of, they calculated from general relativity, about 10 to the 93rd grams per centimeter. It's more like, it's probably infinite. That was just a general relativity calculation based on squeezing it off like a black hole calculation. So what it is evidence is an electric flux, a flux of energy from a higher dimensional space. So can self-organization occur? Everybody said no, it violates entropy. And then Prigogine wins the Nobel Prize for saying no, under certain circumstances it can self-organize, and those circumstances have to be nonlinear, far from equilibrium, with the energy flux, and that was Wheeler's model. The energy flux is coming from a higher dimensional space. It enters and leaves. If there's vorticity in the flux on the right, it forms the elementary particles. It's like the particles are the whirlpool. They constantly need to be fed by the stream, and the whirlpool needs the flux to continue always. And the pace of time is associated with the flux. If there is slight tilt to it, we call it vacuum polarization. And if the energy comes through incoherently, that's just background vacuum fluctuations. This is the orthogonal flux model of zero-point energy. It's basically John Wheeler's model. Robert Laughlin sees the same thing. He won the Nobel Prize. He wrote this book, Inventing Physics from the Bottom Down, a Different Universe. His point of view is everything arises from collectives, including the laws of physics themselves. The principles for coherent zero-point energy just do what Prigogine said to do. Work with a highly nonlinear system like plasma, abruptly drive it far from equilibrium, abrupt pulsing, maximize the interaction with the zero-point energy, typically using the ions and creating vortex forms. Electron clouds make very few, electrons make a poor transducer to affect the vacuum energy. The electron cloud in a conductor is essentially in thermodynamic equilibrium with it. You don't really get much in the way of vacuum activity with normal electrical circuits. However, the ions, the nuclei, have steep lines of converging vacuum polarization, and so any abrupt movement of the ions then starts to kick up the zero-point energy. They see it in the accelerator experiments. They call it exotic coherent vacuum states. They see it in the plasma ion acoustic mode, where the ions are moving synchronously together. The plasma ion acoustic mode is famous for manifesting energetic anomalies. The anomalies often center around a self-organizational event, like a toroid, and they see large radiant energy absorption, high-frequency spikes, runaway electrons, anomalous plasma heating, and they're seeing it in the plasma experiment. The type of cluster that's unusual is the inert gas clusters, and in them they can do laser excitation of a mixture of inert gases. When they make the cluster, they get anomalous release of energy. So this inert gas cluster is like an excimer. It's in a kind of a cold plasma state and can be re-excited to release the energy.